Hello and welcome. This video is going to be a revision for the vectors chapter in mechanics. This is going to be an all you need one-stop shop video to solve the ideas coming in mechanics. I got questions that cover most and if not all of the ideas that come in the mechanics exam. So please watch, stay around, stick to the end. This is all you're going to need for the upcoming mechanics exam. So first what I'm going to do is I'm going to give you a quick revision on vectors. So vector is basically a way of representing something that has magnitude and direction. Let's say we have a xy plane like this, x and y, and we want to describe the velocity of an object. So velocity has a magnitude and direction. So how to represent it? Using a vector, which is an arrow that points in a specific direction. The length of an arrow describes the magnitude. The direction of the arrow, or the angle of the arrow, describes the direction. So all vectors are written in a notation called I and J notation, or there is a notation where you write two numbers on top of each other in a bracket, where the top number is the I and the bottom number is the J. What is I and what is J? I is basically a vector that is 1 unit in the positive x horizontal direction. J is basically 1 unit in the positive y direction. So let's say if I know that there is a velocity vector that goes like this, it's 3i and 4j, let's say. So 3i plus 4j, that is my velocity vector. That means that my vector is 3 units to the right and 4 units up, so the vector looks something like this. This is the magnitude and the direction. How do I find the magnitude of a vector? Because if I told you, okay, what's the value of the velocity? Magnitude is basically Pythagoras of the vector. So we're going to take the square root of the I component squared plus the j components here, so that's 9 plus 16, which is root 25, which is equal to 5. The magnitude is 5 meters per second. This is magnitude. What about direction? To get direction, what I can do is I can get this angle, which is relative to the positive x-axis. So what I'm going to do is I'm going to use trigonometry. I know that tan theta is going to equal opposite, which is 4, because this length over here is 4, over adjacent, which is 3. And then if I want theta, I will do shift tan of that. So theta equals shift tan, or tan inverse of 4 over 3. That is going to give me around 53 degrees. So this angle is 53 degrees. I know exactly which direction is this vector or this velocity going to, and I know the exact magnitude. So this is the beauty of vectors. Okay. Something that is super important when dealing with vectors, and we're gonna use it a lot today, is something called the position vector. Okay, let's say the position of the particle, this particle has a position of in 3 in the x direction and 4 in the y direction. So this is the position of the particle relative to this origin, okay? And this particle is still. So as the time passes, this position doesn't change. So the position vector of this particle stays this vector over here, which is 3i plus 4j. Let's call this point A or something. So it's going to be OA. Okay, that if is the if the point is still. What if the point is moving with a constant velocity? So this point is moving with a velocity. Let's say the velocity is 2i. So it's just moving 2i meters per second. That means that every second it moves 2 units in the I direction and 0 units upwards. So at time t equals 0, this is the position of the particle. After 1 second, the particle would have moved 2 units, so it's going to be over here. So now, initially, the position vector was this green vector over here. However, after 1 second, the position vector changed. Position vector meaning the position of the particle relative to O. So in another word, and I'm saying that the position vector or the position of the particle keeps on changing. Okay, it depends on which time second or which second are we looking at. Okay, so how do I get a formula to tell me where is the position of the particle going to be at this time. So I just need a formula where I can plug in the time, okay, and it's gonna straight away give me the position vector. This formula goes like this, and it's very important. I'd love if you wrote it down. Let's call this particle S, okay? So S is the position vector, okay? So the position of S is going to be S of 0 plus the velocity of S times time. What does that mean? The position vector is going to equal the initial position vector, so the position vector at time t equals 0, which was this one over here. Adding to that, the velocity vector multiplying by the time that I want. So if I want the time at t equals 10 seconds, so I'm going to replace 10 over here, and I'm going to do this calculation. Okay, I'm going to find the final position vector at the time t equals 10 seconds. So this is basically how you can get the position vector. We're going to use this a lot. So please take note of this. And I believe you know that vectors, we can add them. So let's say if I have 4i plus 3j, this is one vector, plus negative 2i minus 3j, for example. So I can add the vectors, so add the I components together. So 4 minus 2 is going to be 2i, and 3 minus 3 is going to be just 0j. So the final answer is going to be 2i. So vectors could be added or subtracted to each other. One more thing is that if a vector is, if I'm multiplying a scalar, just a scalar coefficient to a vector, 2i plus 5j, for example, this is going to equal, I'm going to distribute this, so it's going to be 8i plus 20j. That is going to be the unit vector. Another thing that we're going to use a lot is that the idea of parallel vectors. Let's say this vector is like this, and I have another vector which is like this. So these two vectors are parallel. It means that they're moving in the same direction. Okay, so to do that, or to express that, if let's say vector A is parallel to vector B, that means that vector A is equal to some constant, some number, multiply vector B. Okay, and I'm going to show you how we use this. Finally, before starting solving, I want you to know something that is called a unit vector. Okay, let's say we have this x and y plane. We have this vector over here, which is 3i 4j. A unit vector is basically a vector in the exact same direction of my vector. So the unit vector of this vector v, for example, the unit vector of vector v is going to be another vector which is exactly in the same direction as v, however it has a magnitude of 1. Okay, so the length is going to be 1. Okay, so this is going to be the unit vector. How do I calculate the unit vector? It's using this formula over here. Unit vector is equal to my vector v over the magnitude of vector v. So if vector v here is 3i plus 4j, I need to divide this by the magnitude of vector v. How do I get the magnitude again? We said it's Pythagoras, so it's going to be 3 squared plus 4 squared. That's square root 25. That is basically 5. So the unit vector is going to be 3 over 5i plus 4 over 5j. That is the unit vector. If you try to get the magnitude of this vector doing the I component squared plus the j component squared, you should get a magnitude value of 1. If you try that on the calculator, I'm doing it right now, 3 over 5 squared plus 4 over 5 squared, that's going to give me a magnitude of 1. So it's basically a vector in the same direction as v, however it has a magnitude of 1. Now let's continue to solving the past year questions. These are actual past year questions. I got most, or if not all, of the ideas that come in the vector questions, so you guys can practice a lot. I'm going to solve a lot. The best way to learn or to be better at something is to do the tedious solving. So I said I'm going to do that for you guys. Just follow along, try to solve, and if you have any questions, you can leave them down below. And by the way, stay tuned to the end of this video because I have something that's super beneficial for you guys. I'm going to reveal it at the end of the video regarding mechanics. So mechanics students would really love it, I'd say. Anyways, let's start by solving question 7. So let's read the question. Question says, we have two ships, P and Q, and they are traveling at night with constant velocities. So they're traveling with constant velocity. At midnight, P is at the point with position vector. So this is the position of point P at midnight. Is P moving or is it at rest? P is moving with constant velocity. So after 1 hour, I'd expect this position to change. Okay, this is what I want you to think about. So the position vector is 20i plus 10j kilometers relative to a fixed origin O. At the same time, Q is at the point position vector this. 3 hours later, P is at the point with position vector. So after 3 hours, P changes its position because it's having a velocity. This is the final position after 3 hours. The ship Q travels with this velocity. At time t hours after midnight, the position vectors of P and Q are P and Q respectively. This is the general position vector equation that I told you is super important and I started it a while ago. So let's see how we can solve that. So the question wants the velocity of P in terms of I and J. Okay, so over here, I know that I have the initial velocity. I have, the initial position and the final position. So if I subtract these two positions from each other, I'm going to get the displacement S of particle P. And I know that velocity is equal to displacement over time. So if I want the velocity of P, I need the displacement over time. I know that time was 3 seconds. Displacement I can get by subtracting the positions. So let's see how we can do that. So for this, let's do the final position, which is 29i plus 34j, minus the initial position, which is 20i plus 10j, all over the time it took, which was 3 hours. Here our units are kilometers per hour, so we will leave it like this. So the velocity is going to be 29 minus 20 is going to be 9i, plus 34 minus 10 is basically 24j over 3. So 9 divided 3 is going to be 3i, okay, plus 24 divided 3 is 8j, and that is going to equal the velocity vector of P. The question here wants the velocity in terms of I and j, so I'm going to leave it. If it asks for magnitude, then I'm going to do square root of 3 squared plus 8 squared to get the magnitude. So now we solved the first question. Let's not forget the unit. This is in kilometers per hour. Okay. Question B, this is A. Question B says expressions for P and Q in terms of T. Okay, so now we basically want the position vectors of P and Q in terms of T. So this is the equation that I told you about. So the position vector of P is going to equal the initial position of P plus velocity of P times time. So this is going to equal initial position of P was 20 plus 10j. So that's going to be 20i plus 10j plus the velocity vector of P, which I got as 3i plus 8j. So 3i plus 8j into the time. And this is the general position vector for P. What I like to do is I like to group the i's together. So I know that this t is going to multiply inside. Is going to be 3ti plus 8tj. So I'm going to do 20 plus 3t plus 3t. That is going to be the I component, plus 10 plus 8t. That is going to be the j component. And this is the position vector of P. Now let's do the same for Q. This is going to equal q0 plus vq times time. So what is q0? Initially, point q is at this position vector, so 14i minus 6j. So it's equal to 14i minus 6j plus vq. What is the velocity for q? It says that the ship travels with a velocity of 12j kilometers per hour. So the velocity is going to be 12j, basically 12j times time, or 12tj. Now what I'm gonna do is I'm gonna write it in this notation. I like all the I components to be together. So the only I component here is just 14. So it's gonna remain as 14I plus -6 plus 12t in the J. And this is going to be my general position vector for Q. So this is me solving part B. Now, the question says, at time t hours after midnight, the distance between P and Q is d kilometers. Okay, so if P is here and Q is there, this distance, okay, we call it d kilometers. Okay, by finding an expression for PQ, show that d squared is equal to this. And it's a 5 marker. Okay, first of all, I need the distance. Okay, so the distance, I need to find the vector PQ. Okay, or the vector from P to Q. So to do that, know that the vector PQ is going to equal Q, the vector Q minus the vector P. And over here, I got the vector Q as 14I plus -6. So 14I plus -6 plus 12tj. And then vector P was this vector over here, which is, so I'm going to subtract vector P, which is going to be 20 plus 3t in the I plus 10 plus 8t in the J. So let's subtract them together. Let's subtract the, okay, this is a big minus. You have to subtract the whole of vector P, so you have to put it in brackets. So it's going to be 14 minus 20 minus 3t. That is going to be the I component. And then plus, I'm going to have -6 plus 12t minus 10 minus 8t in the J component, because I distributed this minus into everything basically. So this is what I end up with. So 14 minus 20 is -6 minus 3t in the I plus -6 minus 10 is basically -16. And then 12t minus 8t is plus 4t in the J. Okay, so this is basically what I have turned out. This is vector PQ. To find the distance, okay, you do Pythagoras of PQ. So to find the distance, I'm going to do square root of the I component, which is -6 minus 3t squared, plus the J component, which is -16 plus 4t, all squared. And this is going to give me the distance, right? The question wants me to show a distance squared, so I can square root both sides. So I'm just going to be left with these two brackets, and on the right side I'm going to have d squared. So let's start by expanding. So expanding a binomial like this, I like to do it this way. So I like to say that it's the first term squared, so -6 squared is 36. First term times second term, so positive 18t times 2 is positive 36t. And then last term squared is going to be plus 9t squared. Then plus 16 squared is 256. And then first times second, so -16 times 40 times 2, that's going to give me -128t. And then last term squared, 40 squared is 16t squared. And all of that is equal to d squared. So now let's simplify. 9t plus 16t squared is going to be basically 25t squared. 36 minus 128. I'm basically adding like terms. That's going to be minus 92t. And then 36 plus 256 is basically 292. And all of that is equal to d squared. And this is exactly what I was told to show. Okay, this is a 5 marker, a typical 5 marker. So what we can do now is erase this, okay, and we can solve over here. Okay. Part C says weather conditions are such that an observer on P can only see the lights on Q when the distance between P and Q is 15 kilometers or less. Given that when time equals 1, the lights on Q moves into sight of the observer. Or in other words, P and Q, the distance between them is now 15 kilometers, right? Find the time to the nearest minute at which the lights on Q move out of sight of the observer. So we basically want to find the time where the distance between P and Q starts to become greater than 15 again, so they will be out of sight from each other. Okay, so to do that, what we can do is we can place the distance, okay, because we already got this as the distance equation. So we want to find the times where the distance is exactly 15. So let's change d into 15. So it becomes 15 squared equals 25t squared minus 92 plus 292. So 15 squared is basically 225. Adding 225 and subtracting 225 from both sides is going to make this side 0, and this is going to be 25t squared minus 92t, and then 292 minus 225 is basically 67. So now I can see that this is a quadratic equation. What I can do to solve this is use the quadratic formula. So I'm not going to go through this in this video, but I have a complete playlist showing you how to solve and deal with quadratics. I'm going to leave it on the top right hand corner. Feel free to check it out. What I'm going to do is I'm going to do the quadratic formula, which is going to be minus b, so positive 92 plus or minus square root of b squared, so negative 92 squared, minus 4 times a, which is 25, c, which is 67, and all over 2 times 25. That is going to give me two answers. If I plug that quickly, I'm going to have 2 squared minus 4, 25, 67 over 2 times 25. So the first answer, when this is plus, is going to be 2 time equals 2.68 hours after midnight. And the second answer, when this is minus, I expect it to be 1, because over here it told me that when t is 1, the distance between them is 15. So 92 minus 4 times a times c over 2a. Yeah, so the other time is basically t equals 1. So this is a quadratic that goes something like this, okay? If this is 15, we have 2 times where it crosses 15. We have 1 time at t equals 1, okay? And we can see that during all of this time, the distance is basically below 15. So they are in sight of each other. And then at 2.68, it starts to become 15 again. But then after that, the distance is going to start to be higher than 15, as we see. So they're going to move out of sight from each other. To get this in to the nearest minute, we know that this is 2 hours plus 0.68 hours. So to change 0.68 to minutes, you multiply 0.68 times 60, which is going to be 40.8 minutes. So 2 hours and around 41 minutes after midnight. This should be your final answer. So this is the first question, a very typical question that comes a lot in the mechanics exam. So I hope it was clear. Let's now move on to the next question. Let's read the question. This is another question. So at time t equals 0, a football player kicks a ball from the point A with a position vector. So this is the position of point A on a horizontal football field. The motion of the ball is modeled as that of a particle moving horizontally with a constant velocity of vi plus hj. Find the speed of the ball. So speed is basically equal to magnitude of velocity. So basically the magnitude of velocity. So to get the magnitude of velocity, I'm going to do 5 squared plus 8 squared. That is going to equal around 9.43 meters per second. So this is part A of the question. Now the question says the position vector of the ball after t seconds. Again, a similar question, wanting to find the general position vector. That's why I told you it comes a lot. So the formula, let's call the ball B. So B is going to equal B0 plus velocity of B times time. So it's going to equal B0 is the initial position vector of the ball, which is 2I plus J, plus velocity of the ball, which was 5I plus 8J into time. Let's group all the i's together. So this is going to be 2 plus 5t in the I plus 1 plus 8t in the j. This is the position vector. Okay. Now, question C says the point B on the field has a position vector of 10i plus 7j. Find the time when the ball is due north of point B. Okay. Let's say this is point B over here, which is 10i and 7j. So this is point B. Yeah. The ball is moving. Okay. Let's say it's moving with a constant velocity. So the ball, let's say, started from here and is moving this way. So at a certain point, the ball is going to come and is going to be exactly north of point B. So exactly on top of point B. If the ball, which is small b, is exactly on top of B, what do you expect? I would expect that they will both have the same x component, right? So this is a hint for me to find when is my ball going to have the same x or the same I component as the point B. So clearly point B has an x of 10. So I want to know when is my ball going to have an I component of 10. So let me equate the I component of my ball, which is 2 plus 5t. Let me equate that to 10. So I'm subtracting 2 from both sides. So I'm going to have 5t equals 8. So here t equals 8 over 5, which is around 1.6 seconds. So after 1.6 seconds, the ball is going to be exactly due north of B because they will both have the same I vector. It could be due south as well, right? How do you make sure? You can make sure that it's north by substituting this time in the J component. I know if I substitute it here, it's going to give me 10. So let's see if we substitute it here. 1 plus 8 into 1.6, that's going to give me 13.8 J. Okay, and that is higher than point B because point B has a J component of 7. This is going to be 13. So now I'm 100% sure that this is going to be exactly north of B. Now, question D is a tough one. So let's try to attempt it. At time t equals 0, another player starts running due north from B and moves with a constant speed v. Given that he intercepts the ball, find the value of v. Okay, so at time t equals 0, when the ball started moving, let's say this is time t equals 0, at the same time there is a player, okay, moving exactly north of B. So his velocity vector, I'd expect it to have only a J component, right? So something only in the J component. It's moving due north. They will both intercept each other. So they will both hit each other. Okay, and the only way they can hit each other is going to happen at this point over here, where it is 10i plus 13.8j, because this player is moving north, and the ball is only going to be north of B at this point. So we want to find the velocity of this guy. So what I'm going to do is I'm going to find using the position vector formula, okay, using the position vector formula where B equals B0 plus velocity of B into T. Actually, what I can do is something else. Yeah, I can actually think of the boy that is running, okay, and try to find his position vector. So the boy, let's call him S, is going to be the initial position of the buoy plus the velocity of the buoy times the time. I know that they have to meet at t equals 1.6 because that is the only time where my ball is going to be north of B. So the position vector of the guy, I know that is going to be 10i plus 13.8j. So this is going to equal the initial position vector of the guy, which is going to be, he started from point B, so it's going to equal 10i plus 7j plus the velocity of the buoy into the time, which is 1.6. And from here, I can find my velocity of the guy. So what I'm going to do is I'm going to move this to the other side. So 10i plus 13.8j minus 10i plus 7j. And I'm going to divide 1.6 from both sides, so 1 over 1.6, that's going to equal the velocity of the buoy. So 10i minus 10i, that is 0. And then 13.8 minus 7, that is going to be 6.8j over 1.6, that is going to equal the velocity. So divide 1.6, that is going to give me a velocity vector of 4.25 j meters per second. So that is the velocity required for the buoy to move and intercept the ball. And obviously the question, if it wants the speed, the question wants the speed, not the velocity. So I need to get the magnitude of this. But since this is already 4.25 g, the magnitude is going to also be 4.25. If you want to test it, you can do the same equation. So I is 0 squared plus 4.25 squared. So this is basically 4.25 squared. Cancel, cancel. So the speed is 4.25 meters per second. And this is the answer for D. Now, E says state one physical factor other than A resistance, which would be needed in refinement of the model. So to basically have a better model, first of all, nothing, if a ball is hit, it will never go with a constant velocity. It's obviously going to slow down. That's one thing. So what I can say is friction, include the friction factor between the ball and the field. That is one thing I can say for 1 mark to refine my model. Okay, now let's try to do the next question. Let me erase everything. Okay, and let's move to the next question over here. Okay, now this question, let's start reading it and trying to solve. So the question says, a model boat A moves on a lake with a constant velocity. Okay, this at a time t equals 0, A is at a point with position vector that. So find the speed of A. So again, speed is going to be the magnitude of the velocity vector. So 2 squared plus negative 10 squared. So that is going to equal square root of 2 squared plus 10 squared. That is going to be around 10.2 meters per second. No, okay, so I got the magnitude of the position vector. That is wrong, okay? What I should get is the magnitude of the velocity vector, okay? So this is wrong. So you need to make sure that it's the velocity vector. So minus 1 squared plus 6 squared. That is going to equal 6.08 meters per second. That is the speed. The direction in which A is moving, giving your answer as a bearing. Okay, so A is moving with a velocity -1 and 6. So this is the velocity of A. Okay? So to get the answer as a bearing, what I need to do is I need to draw, always in bearings, you need to draw a north at the beginning of your vector. So a line that goes to the north direction, and then to get the bearings you need to move clockwise until you hit your vector, and this whole angle is going to be my bearing. So this angle I can split it into 2 halves. This half, which is basically 90 plus 90 plus 90. So this whole angle is 270. And then I need to add this small angle theta. Okay. And I can get the theta using tan inverse of opposite over adjacent, which is 1. So this is going to be shift tan of 6. That is around 80.5 degrees. So the total bearing now, the bearing is going to equal 80.5 plus 270, and that is around 351 degrees, and this is going to be my bearing. So this is part B. Now part C, it says at time t equals 0, a second boat B is moving with the position vector. This, given that the velocity of B is this, show that A and B will collide at a point P and find the position of point B. So first of all, you need to think about colliding. What does colliding means? Colliding means that they're both at the same position at the same time, and the distance between A and B, or basically the vector A, B is 0, because the distance, this is the distance vector. So from A to B, from point A to point B is 0. That means that they're at the same position. That means that they collided. So let's start by finding the vector A. Okay, it's going to be A0 plus VA times T. You already memorized this formula by now. So it's going to equal A0, which is the position vector of A, which is 2i minus 10j, plus velocity of A, which is negative I plus 6. So negative I plus 6j into time. So let me group the i's together. This is going to be 2 minus t in the I plus negative 10 plus 6t in the j. That is the position vector, the general position vector of A. Now we do the same thing for B, which is going to be B0 plus VB times time. So it's going to equal B0 is the position of B at time equals 0, which is negative 26i plus 4j. And then add that into the velocity of B, which is 3i plus 4j. And multiply the velocity vector by time. Let's group i's together again. So negative 26 plus 3t in the I plus 4 plus 4t in the j component. And these are basically my position vectors. Okay, now let's find A to B. A to B is basically going to equal the vector B minus the vector A, correct? So let's do it on this side over here. So vector B, which is negative 26 plus 3ti plus 4 plus 4t in the j. We subtract from that vector A, which is, you do a big bracket, which is 2 minus t in the I plus negative 10 plus 6t in the j. So let's do this subtraction. So what I'm going to have is, I'm going to have negative 26 plus 3t minus 2 plus t. All of that is going to be in the I component, plus 4 plus 4t, and then I'm going to have plus 10t, sorry, plus 10, okay, minus, because this minus times positive 6t is going to be minus 6t in the j. So negative 26 minus 2 is minus 28, 3 plus 1 is plus 4t in the I, and plus 14, 4 minus 6 is basically minus 2t in the j. So this is basically the vector A to B. This is the vector A to B that shows the distance between A and B at any time. Okay, now we're not required to find the distance. We know that we know the distance between them. Collision means that we know that the distance is going to be 0. So I want to find the time where this is 0, so I'm going to equate it to 0. So that means that the I component 28 plus 4t should equal 0. Okay, and the j component also for that time would be equal 0 if they will collide. So this is going to be negative 28 over negative 4, because I'm going to move this to the other side, equals t. So the time is going to be 28 divided 4, which is 7. Is this in hours or is it in seconds? Let's check. This is in seconds. So 7 seconds, that's where the I components are going to be the same. Okay, if we substitute a 7 over here, so 14 minus 2 times 7, that's also going to be 0. So at 7 seconds, the distance between A and B are going to be the same. What I could have done is also equated the I vector over here to this I vector over here, because I know that I need to find a time where the I vectors are equal. So if we did that, 2 minus t equals negative 26 plus 3t. So 4t, 28 equals 4t. So again, it will give us a t equals 7 seconds. That would have been much faster, but I wanted to show you how to deal with the distance between two vectors. Okay, so now the question wants us to find the position vector of the point P. So where is the position of point P? So I can just basically substitute 7 seconds into either A or B to find the position at that time. So what I'm gonna do is I'm gonna substitute it in A. So I'm going to have 2 minus 7 in the I. I'm substituting it over here. 2 minus 7 in the I plus negative 10 plus 6 into 7 in the J, and that's going to give me minus 5I, and minus 10 plus 6 times 7, that's going to be plus 32J. So this is the position of A at 7 seconds, and I know that at 7 seconds is going to be the point of collision. So this is also the position of the point of collision, which is point P. It has a vector, a position vector of negative 5 plus 32J. Now, question D, let's erase this. I don't think we need it. So, question D is also a tough one. It's a 6 marker. So let's see how we can approach it. Given that, given instead that B has a speed of 8 and moves in the direction of this vector, find the distance of B from P when t equals 7. So I'm given that B has a speed of 8 and moves in this direction. I was not given the velocity vector. I was just told that the velocity is in this direction and it has a speed of of 8. So speed of 8 means that the magnitude of the velocity vector is 8, right? And I know that if the velocity vector is moving in this direction, okay, it means that they're parallel. It means that the velocity vector is going to equal a k multiply my direction, 3i plus 4j. This is going to be the velocity vector over here. So what I'm gonna do is I'm gonna write this as v equals 3ki plus 4kj. That is going to be v. And I know that the magnitude of this v is going to equal 8. So if I got the magnitude, which is the I component squared, so 3k squared plus 4k squared, this should equal 8. So what I'm going to do is I'm going to square both sides. Okay. So over here, I'm going to have a 9k squared plus 16k squared equals 64. So 9 plus 16, that is 25k squared equals 64. Divide 25, divide 25. K squared equals 64 over 25. Square root of both answers, k of both sides, sorry, so k is going to be 8 over 5. So now I know that k is 8 over 5, and I can say that my velocity vector is equal to 8 over 5 times my direction. So that is my velocity vector of B. Why did I do all that? Because to find the distance of B from P, I will need to know where is the position of B at t equals 7 seconds, okay? And I already know the position of P. I already got it. It's negative 5 plus 32. So to get the position of B, we obviously need to find the velocity vector of B, because the general position vector of B now is going to equal B0 plus the V B which we got over here, which is this new velocity, times the time. So B is going to be at the position of B0 is the same. So it started from this position vector. It didn't say anything, the question. So it's going to be negative 26I plus 4J. Then we add to that the velocity vector that we found, which is 8 over 5 times 3I plus 4J. So 8 over 5 times 3I plus 4J, and we multiply that by the time we are interested in, which is 7 seconds, and that is going to give us the position at B. So I'm just going to do that. This is going to be negative 26I plus 4J plus 8 over 5 times 7 is basically 56 over 5. Multiply that by 3 one time is going to be 168 over 5I plus multiply the 56 over 5 times 4. That is going to be 224 over 5J. Adding these two together is going to give me a position of B of negative 26 plus 168 over 5. That is going to be around 7.6. It is exactly 7.6I plus 4 plus 224 over 5 is going to give me 48.8J. So now this is the position of the position of B at the 7 second, at t equals 7. Okay, so now to find the distance of B from P, what we do is we need to find BP, this vector, and get its magnitude to find the distance. So BP means the vector or the position P minus B. So what I'm gonna do is I'm going to rewrite P over here. P was 5I plus 32J. Okay, and we need to subtract that. So let's say BP. We need to subtract vector B, which we just found as 7.6I plus 48.8J. So that's going to give me a final answer of 5 minus 7.6, negative 2.6I. And then 32 minus 48.8, that is negative 16.8J. And to find the distance, okay, I'm going to, wait, this is negative 5. This is negative 5. So minus 5 minus 7.6 is not 2.6, it is 12, negative 12.6. 5 minus 7.6 is, yeah, is negative 12.6. So to find the distance, okay, BP, or let's actually write it properly. This is the vector. The distance is going to be the magnitude of this vector over here, which is going to equal negative 12.6 squared plus negative 16.8 squared. That is going to give me an answer of 21 meters, and this is going to be my final answer. It's not a tough, it's not an easy question. It has lots of ideas and lots of steps, but usually it's best to actually try to understand what is happening to be able to approach these types of questions. So let's delete all of this and let's continue solving the next question. So this next question is looks like an application of vectors. So we're dealing with forces here. So a particle P of mass 2 kilograms is moving under the action of a constant force, F newtons. This question comes a lot. When t equals 0, P has a velocity of 3I plus 2J, and at time t equals 4, P has a different velocity. So now we're not moving with the same velocity, we're changing velocity. So probably we have acceleration. So, and indeed the first question, the first part is asking me about the acceleration of P in terms of ing. So acceleration, we know that from the formula, is the change in velocity over time. So change in velocity is going to be the final velocity vector, which is 15I plus 4j, minus the initial velocity vector, which is 3I plus 2j, over the time it took, so which is 4 seconds. So that is going to equal 15 minus 3 is 12. 12 divided 4, that is going to, or let me write it for you so you follow, plus 4 minus 2 is basically 2j over 4. So that is going to be 12 divided 4 is 3I, and 2 divided 4 is 0.5j, and the unit is meter per second squared, or meter second to the power of negative 2. So that is the answer to part A. Part B says find the magnitude of the force F. So here you need to be familiar a little bit with some physics. You need to know the Newton's second law, that the F, or the force, is equal to mass times acceleration. So force is going to equal to mass, which is 2 kilograms, times the acceleration, which we already got as 3I plus 0.5j. So that's going to equal 6I plus j newtons. And the question wants the magnitude. So we get the magnitude of F, which is going to be square root of 6 squared plus 1 squared. So that is going to be this is, yeah, there is a small mistake over here. This is not plus, this is minus 4j, so that's going to be minus 4 minus 2, so that's going to be 6, minus 6 actually, minus 6, and then this part over here is going to change. So minus 6 over 4 is basically minus 3 over 2, or minus 1.5j. And over here is also, this is going to be minus 1.5j. Multiply 2 is basically minus 3j. So this is minus 3j. And over here, I'm going to add not 1 squared, I'm going to add minus 3 squared. So that is going to be square root of 6 squared plus negative 3 squared. That's going to give me an answer of 6.71 newtons. That is going to be the magnitude of force F. The velocity of P at time t equals 6. So this is also a little bit of kinematics. What I know from here, I like to write down my givens in kinematics. And by the way, I've done a full revision on kinematics for mechanics. It's a very, very good video that solves lots and lots of questions. Feel free to go check it. I'm going to leave a link to it on the top right hand corner. So in that video, and usually in kinematics, what I like to do is write my givens. So over here, I have my acceleration vector, I have my initial velocity u, I have my final velocity v, and sorry, I don't have my final velocity. This is what I'm trying to get, okay? And I have the time that I'm interested in, which is 6 seconds. So over here, I have acceleration, I have time, I have initial velocity, and I don't have, but I want final velocity. So the only letter that I didn't mention out of the 5 quantities is displacement, okay? So I'm going to use the kinematics equation, the Saviot equation. I'm going to use the one that does not include distance, which is basically v equals u plus a t. So v, which is the thing that I want, is going to equal u, which is the initial velocity vector at time t equals 0, which is 3i plus 2j. Here you can have your initial velocity vector as 15i minus 4j. However, if your starting point is here, then your starting point at time is here as well. So the time taken from 4 to 6 is going to be 2 seconds. So you can feel free to do that. However, the time is no longer going to be 6, it's going to be 2 seconds. This is something on the side for you if you have a question, but I like to start from the beginning because it's more logical. So plus acceleration vector was this vector over here, 3i minus 1.5j, and multiply the time, which is 6. So this is going to be 3i plus 2j plus 3 times 6 is 18i. Negative 1.5 times 6 is minus 9j. So 3 plus 18, that is going to be 19, 20, 21i. 2 minus 9 is going to be minus 7j. And this is going to be my final velocity vector. Does the question wants the magnitude? Probably meter per second. So we can get the magnitude by saying that we're just going to do v is going to equal square root of 21 squared plus negative 7 squared. This is going to be 22.1 meter per second. This is my final answer, or if you want it as I and J notation, you also have got it over here. So no issues at all in this question. Now, let's solve the next question. So this next question is also looks like it's an application where we have velocities and accelerations. So a particle P moves with a constant acceleration, okay, at time t. So since it says constant acceleration, I know that I can use my Saviot equations, okay, the constant acceleration equations. At time t equals 0, P has a speed of u. Time t equals 3, P has a velocity of this. Find the value of u. Again, let's solve this using the kinematics way. My givens are acceleration. I have the time it took. I have it. I have my final velocity, v, and I need u. So again, which letter didn't I mention? Displacement. So I'm going to use v equals u plus at. So v, which is negative 6i plus j, equals the u plus acceleration, which is 2i minus 5j, into t, which is 3 seconds. So over here, I'm going to multiply this. So this is going to be 6i minus 15j. I'm going to move it to the other side. So it's going to be minus 6i plus j. I'm going to move it to that, so it's going to become minus. So minus 6i, and then minus times minus is going to be plus 15j. That's going to give me my vector u. So minus 6 is basically minus 12i. 1 plus 15 is 16, so 16j. That is the u vector. If I want the velocity or the actual speed, I'm going to do square root of negative 12 squared plus 16 squared. That is going to equal 20 meters per second exactly. And this is how to solve this question. So vectors, you need strong foundation in kinematics as well. If you know how to deal with kinematics, you're going to make your life way, way easier in these questions. So let's get into the next question. Question says we have two forces, 4i minus 5j and pi plus qj, act on a particle of mass m kilogram. The resultant of the two forces is r. Given that r acts in the direction which is parallel to the vector this, find the angle between r and the vector j. So before I go into the parallel and the scale thing, let's do A first. A is easy. It tells you find the angle between R and J. I don't need the exact vector of R. I know that I don't have the vector R. I just have the direction where it goes into. But the direction of R, let's say this is the actual R vector, and I want to find the angle between it and the J vector. So I want to get this angle. I don't actually need the vector R, because if I know its direction, so if I have another vector which is in the same direction of R, let's say this vector over here, I can find the direction between, or sorry, the angle between this green vector and J, and it's going to be the same as the angle between R and J, because they all move in the same direction. So this is what I'm going to do. I'm going to use this direction vector, find its angle, find the angle between it and vector J. So let me draw it first. So this angle, let me draw something like this. So this vector, the direction vector, is basically I minus 2j minus 2. So it's something like this, and I want its angle between it and the vector j. So where is the positive vector j? It's this vector, so I need all of this angle. So I know that this part is 90 degrees, so what I need is just this small theta and add it to 90 to get the angle. So I know that this is 2 and I know that this is 1. So what I'm going to do to find theta, I know that tan theta is going to equal opposite, which is 2, over adjacent, which is 1. So theta is going to equal tan inverse of 2 over 1. Theta equals shift tan 2 over 1. What I like to do is never put negatives in my trig angles questions. I like to draw the question, know exactly where everything else, split it into small parts and add it logically, because this is how I know that I don't make any mistakes. Because here you might tell me, okay, j is negative 2, why did you put positive 2 over here? That's what I do. Yani in trig, it's better to draw, because sometimes this can cause confusion and mistakes. So this is what I like to do. 63.45 degrees is the theta. So my answer for A is going to be 90 plus 63.45. So plus add them to each other. So my final answer is going to be 153.4 degrees. So this is going to be my angle. Now question B says, show that 2p plus q plus 3 equals 0. So we want something that, an equation basically for p and q. So what I know from here is that R is the resultant of these two forces. And basically, let me erase this part, I don't need it. And let's start doing part B over here. So I know that the resultant of two forces is basically the addition of those two forces. So I know that 4i minus 5j plus pi plus qj is equal to the vector r. I don't have the vector r, however, I have the direction of vector r. So vector r is going to be some constant multiplying this direction, which is I minus 2j. So let's substitute that. So let's call this k into I minus 2j, right? So over here, what I'm gonna have is the I component plus this I component should equal this I component. So 4 plus p should equal k times 1 or k, right? This is my first equation. And similarly for the j, I need to have the minus 5 plus the q equal to k times negative 2, so equals to negative 2k. And from here, I can eliminate the k and get an equation for p and q only. How I'm going to do that is, let's say this is 2 and this is 1. I'm going to divide them by each other. So I'm going to divide the top by the bottom. So I'm going to have 4 plus p over negative 5 plus q. That's going to equal k over negative 2k, which is basically the k's will cancel with each other. That's going to be negative 1 over 2. I'm going to cross multiply. So this is going to be 2 into 4 plus p equals negative 1 or negative 5 plus q, and basically expand from here. So 8 plus 2p equals 5 minus q. Now I need everything on one side, so I'm going to have 2p. I'm going to move this over here. It's going to become plus q, and I have this plus 8 minus 5. So this is going to be 2p plus q. 8 minus 5 is positive 3 equals 0. And I believe that this is what we were supposed to show over here. Now, given that also q equals 1 and that p moves with an acceleration magnitude of this, find the value of m. Type straight away, I know if q equals 1, I can find p straight away. So if q equals 1, 2p plus 1 plus 3 equals 0. 2p equals 1 plus 3 is 4. Move it to the other side is negative 4. So p equals negative 2, basically. Right? So that is my p. Now I need to find the value of m. So I can do that by getting the resultant, the actual resultant force now, because it's going to be this force and this force. And now I know what is p and what is q. So let me erase all of this. Don't need it. And let's continue from the top over here. I know that P is -2, Q is 1. So 4i minus 5j plus negative 2i plus j is going to equal 4 minus 2 is basically 2i. Negative 5 plus 1 is minus 4j, and that is going to be my vector r. This is the resultant vector, and I know that from Newton's second law that my resultant force, the resultant force is equal to mass times acceleration. So what I can do is I can get, because I already have the magnitude of the acceleration, I can get the magnitude of this force, r, which is square root of 2 squared plus negative 4 squared. So that is going to equal square root of, so around 2 root 5 newtons, and then I can substitute it here. So 2 root 5 is going to equal mass times acceleration, which is 8 root 5. Root 5 and root 5 will cancel. Mass is going to equal divide 8. So mass is going to equal 2 over 8 or 1 over 4 kilograms. And this is going to be my final answer for this question over here. Let's erase all of these. Okay, we have the last question for today, but before I solve the last question, I want to tell you about the gift I wanted to give it to you. I've done a complete mechanics course where I go through lots and lots of questions like these, even more for every single topic of mechanics for both Edexcel and Cambridge. It's a very, very useful course. It's on Udemy. Please go check it out. It's very helpful. It's intended to replace tuition, to replace school, because when I was your age, I would have really hoped someone that can give me a course for the fraction of what I paid for tuitions that will continue with me for the whole year, with lots of materials, lots of practice. So I can basically both save my money from tuitions and as well get a very, very good mark. So I'm gonna leave the link to it is in top right hand corner, and you're gonna find it in the description. And the gift that I'm gonna give you is that if you email me, but I'm gonna do that to the first 20 people to email me, I'm going to send you either a very, very good discount link that you can use to do your course. I'm gonna do that. I don't usually do that, but that's a one-time thing for you guys because we're very close to the October-November session. So if you would like, email me on my email in the description. Tell me, just mention the title as Udemy Mechanics course. I'm gonna send you the link straight away. Anyways, let's think about this last question over here. So it says that a ship is moving along a straight line with a constant velocity. At time t hours, the position vector of s is small s. When t equals 0, s is this, so this is my initial position. When t equals 4, s is that. Find the speed. So again, speed is basically going to equal the magnitude of the velocity vector. So what we can do is we can find the velocity vector s. No, let's call it v. So it's the magnitude of v, so magnitude of the velocity. So v itself is going to equal the change in displacement over time. So the change in displacement is the change in position over time. So it's going to be the final position minus the initial position, so 21i plus 10j, minus the initial position, which is 9i minus 6j, all over the time it took, which is 4 seconds. So over here, I'm going to have 21 minus 9, I believe that is 12. Yes, so 12i, and then 10 minus negative 6, so plus 16j, all over 4. So that's going to be 3i plus 4j. Meters, no, this is in kilometers, hour per negative 1. So to find the magnitude, I'm going to do 3 squared plus 4 squared, and that's going to be root 25, which is 5 kilometers per hour. That is the answer to part A. Part B says find the direction which S is moving if your answer is a bearing. So basically you want to find the direction of this velocity vector. So again, directions, I like to draw what is happening. So I know that I move 3 units I and 4 units up. My direction, the question wants it as a bearing. Okay, so bearing is also an important thing to know, that I draw a north from my initial position, and then I move clockwise until I hit my vector. So basically the bearing is going to be this angle, and I know that the opposite of this angle is going to be this length, which is 3. The adjacent is going to be 4. So tan theta equals opposite over adjacent. Theta is going to equal shift tan, or tan inverse of 3 over 4. That's going to equal 36.9, or basically rounded to 37 degrees. So my bearing is going to be 0, 3, 7. That is my answer for the bearing. Okay. Now this is part B done. What I need to show now is that S is equal to this. So again, the general position vector of S. So what I'm going to do is I'm going to delete all this. I'm just going to leave the velocity vector because this is what I need. So again, position, general position vector S is going to equal S0 plus the velocity S times T is going to equal S0, which is the position at T equals 0, which is 9I minus 6J plus the velocity vector, which is 3I plus 4J into time. So I'm going to group all the i's together. So 9 plus 3t in the I, okay, or basically 3t plus 9, same thing, minus 6 plus 4t in the j, or basically 4t minus 6j, that's the same thing. So you can rewrite it or leave it like this, up to you, no issues. Now, part D is the tough part. Okay, so let's read it. It says that there is a lighthouse located at this point with this vector. When t equals time, capital T, the ship is 10 kilometers from this lighthouse. Find the possible values of t. So the distance between my ship and L is 10. So S to L, this vector, I'm going to have its magnitude equal to 10. Okay, this is where I want to find the time. So first of all, let's find the vector S to L, or actually, yeah, let's find the vector S to L, which is basically L minus S. So L is basically this position, 18I plus, so it's equal 18I plus 6J. And then we minus S, which is this one over here, which is a big bracket, 9 plus 3t in the I, plus negative 6 plus 4t in the j. So now I will have an 18I plus 6j minus, let's group the i's together. So I'm gonna have this 18 minus this I over here. So 18 minus 9, then minus 3t in the I, then plus 6 minus, so minus negative 6, minus negative 6 is basically plus 6, and then minus 4t in the j. So this is going to be 9 minus 3t in the I, plus 12 minus 4t in the j. So this is basically S to L. This is the vector which shows the distance of S to L with respect to time, or at a specific time. So I know that I want to find the times where the distance is 10. So I need to find where is the magnitude of this vector equals to 10. So the magnitude of SL is going to equal big square root of 9 minus 3t, which is the I component squared, plus the j component squared, right? And I need to know when is this going to equal 100. So what I'm going to do is I'm going to square, is equal to 10 kilometers. So I'm going to square both sides. I'm going to have this side, I'm going to expand. So it's going to be first squared, so 81. And then first times second times 2. So 9 times negative 3 times 2 is minus 54t. Then negative 3t squared is plus 9t squared. Plus same thing here, 12 squared is 144. 12 times negative 40 times 2 is minus 96t, and then negative 4t squared is plus 16t squared. All of this is going to equal 10 squared or 100. So 9 plus 16 is 25t squared. Negative 54 minus 96t is basically minus 150t. And then I have an 81 plus 144, that is going to be plus 225 equals 100. So I'm going to do is minus 100 both sides. So this is going to be 0. And this is going to be 225 minus 100 is basically 125. And from here, I can solve this using quadratic. Are they all divisible by 25? Yeah, I can do that, divide and then factorize. However, I just use the quadratic formula straight away. So it's minus b, so minus negative 150 plus or minus square root of b squared minus 150 squared minus 4 times a times c, which is 125, all over 2 times 25. That's going to give me two answers. First one when this is plus, the second one when this is minus. So 150 plus square root of negative 150 squared minus 4 times 25 times 125 over 2 times 25. The first answer is going to be at t equals 5 when this is plus, and when it's minus is going to be at t equals 1, t equals 5, and t equals 1 hour. This is when the distance between the ship and the lighthouse is going to be 10. So these are my two answers, 5 hour and 1 hour. So this is the end of the video. I really hope it was helpful. Please stay tuned because I'm going to do this series for other topics in mechanics. Leave the topics that you want me to do this comprehensive and basically tedious series. I'm just keep on solving. This is what's going to help you actually in the exam. Let me know what topics you want down below. I'm going to read all the comments. Don't forget to email me for the course. Thank you so much for watching and have a nice day.